Hello, everyone, and welcome to another video. Today, we are going to be talking about how to multiply and divide rational expressions. I did a recent video where we discussed how to simplify rational expressions, and what we're doing is basically the same thing when you get down to it. The only thing to consider is that we are going across two fractions, and of course, if we divide, we're going to need to flip the second fraction because that's how we turn a division question into a multiplication question, as you no doubt learned way back in second or third grade or whenever. So I'm going to use two examples over here on the side using just plain numbers to illustrate exactly what we're doing. And then we're going to start tackling this worksheet that I've pulled out here. I can't even credit the worksheet because I'm not sure where it's from. I just happen to have it. But we're going to start with 6 sevenths times 14 over 9. So what I want to think of is 6 is 2 times 3. 14 is 2 times 7 over 7 times 3 times 3. And now what can we cancel? Well, we've got a 3 in the top and bottom that cancels. We've got a 7 top and bottom that cancels. And then we say what's left? 2 times 2 over 3. For the second example, 5/12 divided by 10/3. So this is division. So our very first step, we're going to flip the second expression. And now we'll consider this is 5 over 3 times 4 times 3 over 2 times 5. And now what can we cancel? 5's cancel, 3's cancel, and we're left with nothing on top, so that's a 1. And 4 times 2 on the bottom, that's an 8. So that is exactly how we are going to treat these questions. I know there's a lot on this page, and I don't know that I'm going to be able to do every single question and fit it in. So for the sake of argument, let's suppose that we just cover up the even numbered problems for right now, and we focus on the odds. So with number one, we've got 8x squared over 9 times 9 halves, and this 9 is going to cancel, and we're going to reduce the 2 with the 8 to get a 4, and the result is 4x squared over 1, or just 4x squared. With 9, we're going to cancel a n. You can cancel it with this n, or you can cancel it with the n on the other fraction, doesn't matter. 9, 7, 2, 5, nothing else cancels there, so 63 over 2 times 5n is 10n. All right, number 5, we're going to cancel our 5's. The 4 reduces with the 6, and we are left with x squared times 3 over 2. All right, number 7 is starting to look a little busier. So we've got 7 times m minus 6 times 5m times 7m minus 5 over m minus 6 times 7m minus 5. Now remember, when you've got multiple terms in the bottom, you want to think of that as having kind of parentheses around it. So when I write it like that, you can see that this complete parentheses of m minus 6 will cancel with this m minus 6, the 7m minus 5's cancel, the 7's cancel, and we're only left with 5m. And then we get to our first division. So now we got to rewrite it. So this is equal to 7r over 7r r plus 10 times r minus 6 squared over r minus 6. And so grab a different color here. 7r cancels with 7r. One of the r minus 6's on the top cancels with an r minus 6. And we are left with an r minus 6 on the top and an r plus 10 on the bottom. All right, number 11 gives us our first instance of where we need to execute step number 2, which is that we need to factor. So I'm going to factor out a 25, which makes the rest of the numerator n plus 1 over 5 times 4 over, and I can factor a 30 out of the 30n plus 30. And now we look at what can we cancel. Well, we can cancel an n plus 1. The 25 cancels with a 5 to leave a 5 behind, but then that 5 can also cancel with the 30 over here, which leaves a 6. Oh, and 4 and 6 also reduce, so it's a 3 and a 2. So what do we have left? It's looking like it's just 2/3. All right, number 13, I am slightly out of space, so I'm going to write it over here. X minus 10 over, I'm going to factor that while I'm at it. I'm going to factor out a 7, 5x plus 3. But then I need to flip that other fraction, which means the 7 goes on the bottom. And on the top, we've got 35x plus 21. I'm going to cheat and be lazy and factor that while I'm at it. And, well, I think it's pretty obvious we can just go like that. And that's the end of that. This is an equals, by the way. That's not a minus. So this equals x minus 10 over 7. All right, 15 does not have a division, so we can leave it as written. However, we do need to factor this quadratic up here, the unfoiling variety of factoring. I'm going to cancel the x plus 5s while I'm at it. So we have whatever this is over x minus 7, because everything else is gone. And whatever this is multiplies to -7 and adds to -6 is a -7 and a +1. So those cancel, and we're left with just x plus 1. All right, breaking it down again. 8k over, we can factor out an 8, we can factor out a k. So 8k times 3k minus 5 times, this is a divided by, so this is over 1. And the 15k minus 25 is 5 times 3k minus 5. Now what can we cancel? Well, 8k's obviously, 3k minus 5's. And lo and behold, the only thing that's left is a 5. And minus 8 over 1 times 6 over 10n minus 80. So n minus 8 times 6 over 10 n minus 8. Now you'll notice I wrote this as a single fraction. I did that once before in problem number 15 as well. Because what we are basically doing when we multiply a fraction is we do top times top and bottom times bottom. So these things are going to get mashed together and these things are going to get mashed together. And that's why canceling from like one side over here and one side over there is legit. It's because ultimately we were just going to throw them into a heap in one giant fraction anyway. All right, so we're going to cancel n minus 8s, and the 6 over 10 reduces, and we end up with 3/5. Give yourself a second to make sure you understand why that is. And then 4 times m plus 9 over an m plus 9, which is obviously going to cancel, times m minus 5 over 5m squared. I don't see anything there that we can factor or cancel, but the m plus 9s will drop out. So we've got 4m minus 5, parentheses, or 4m minus 20 if you prefer, over 5m squared. And again, just like I talked about in the simplifying expressions, we do not want to cancel anything here. Do not cancel these m's. Do not cancel the 5's, because the m and the 5 are added, rather subtracted, so that they are separate terms, and therefore you do not want to do that. Right, and finally 23, x plus 3, we're going to think of as x plus 3 over 1. So this is 3 times x minus 2 over 12 x minus 2 times x plus 3 over 1. The x minus 2's will cancel. The 3 and the 12 will reduce. And we don't have a whole lot left. We got the x plus 3 from the other fraction, and we've got the 4 from the left, and that's the whole thing. So that is a rundown of how you would approach these questions. Now, I'm going to hit clear. which is going to remove my white block there. And I'm going to ask, is there anything else that looks interesting with these other questions, or am I just being redundant? So 20 is a little interesting, because if we look at 20 here, this right here is multiple factors going on here, x minus 5, x minus 2, over x minus 2, times x plus 10, over, and then we got another one of these things going on. So multiplies to negative 20 adds up to negative 5 is going to be a minus 4, or 5 and a plus 4. And then cancel x minus 5s, cancel x minus 2s, and we're left with x plus 10 over x plus 4. So the one thing that I kind of need to come back to and hit on here is to remember that anything that is in parentheses is grouped, and it is multiplied against the rest of whatever's in the numerator or the rest of whatever's in the denominator. You can only cancel, remember, only cancel things that are multiplied. That is super important. You need to remember, do not cancel things that are not multiplied. But if you have a parentheses, that means whatever's inside is multiplied against whatever's up against it. So that works, even if what's inside the parentheses is a group of things. As long as you have the same group, top and bottom, it will cancel. So I think that that addresses pretty much what is showing on the screen. Now there are more problems if I scroll down, and they start to look uglier as we get further down here. But they're really the same thing over and over again. So just to pick off a couple for demonstration purposes. Let's take a look at number 35 here. So 35 is going to be an awful expression to factor. 7p squared plus 25p plus 12. I don't know about you, but I am not particularly fond of factoring quadratics when there is a front number. So doing that is actually really tricky. Let's talk about how to do that real fast. There are a variety of techniques, but the way that I like to do it is to multiply 7 by 12, which is 84. And then we're going to look for factor pairs of 84, which is 1 times 84, 2 times 42, 4 times 21. What else goes into 84? A 7 does, I believe. Yes, 7 times 12. And is that it? Oh, I guess the 3's go in. So 3 times 28, and 6 times what? Times 14? Times 14. Okay. And now what we need to do is look for a pair that adds up to our middle number of 25, which is going to be 4 and 21. So what I'm going to do is I'm going to do this by grouping. So I'm going to say it's 7p squared plus 25p plus 12 is the same thing as 7p squared. And then I'm going to use plus 4p and plus 21p in either order. It doesn't technically matter, but I'm going to write the 21p first in this case, because that'll go with the 7 nicely. Plus 4p plus 12. And now what we are going to do is we are going to group them into two pairs. You don't have to write these parentheses, but I'm showing you what's happening. And we're going to do a factoring out of what's left. So we're going to say that I can take a 7p out of this set of parentheses, which leaves behind a p plus 3. And I can take a 4 out of this set of parentheses, which is p plus 3. And then we've got two things that are added, and they each have a p plus 3 in them. So this is no different than if it said like 7px plus 4x, and we go, oh, we can factor an x out of that. Except instead of an x, it's a thing in parentheses. So it is equal to p plus 3 times whatever's left after we factor out, which is 7p plus 4. So yick, that was awful. But that gives us our method for factoring if you need it. Now, there are plenty of other ways that teachers have taught to do these kind of questions. If you prefer a different technique, use a different technique. But I want to demonstrate one way just in case you have a very overzealous teacher who is going to be going extensively into some really tough questions like these are down here. So that's a p plus 3, 7p plus 4. So now our 35, to carry on here, we've got p plus 3 times 7p plus 4. I apologize for the lawnmower sound in the background if you can hear that. Over 6p plus 8 times, all right, this is just 3p plus 8, or minus 8 rather, over, and we've got another terrible fraction. So 21p squared minus 44p minus 32. Okay, so we could do exactly what I did before, multiply the front and back number and try to come up with factor pairs, but we're going to have really big numbers if we do that. What I'm going to do is I'm going to game the system, and I'm going to pretend that I already have a hunch I know what it is, because these are teacher questions and they're rigged to work. I'm going to bet I'm going to get a 3p minus 8. I'm going to bet good money. So what is the other part of 21p squared would be a 7p. The other part of 32 here would be a plus 4. Now let's check. The outer part is minus 12p, and the inner part is minus 56p. And oh, this is a plus 12 rather. Okay, so minus 56 plus 12 is minus 44p. So if we were to do FOIL, we would end up at exactly what that is. So yes, that works out. That's called using the problem to your advantage, because teachers write things that are rigged to cancel. So this is 3p minus 8 times 7p plus 4. And sure enough, a whole bunch of stuff cancels. This cancels. And this cancels. And I guess the rest of it is left behind. So 35 is equal to p plus 3 over 6 quantity p plus 8. So yes, that is absolutely horrible to factor. The good news is that sometimes there are other better ways to factor. I came up with a couple thoughts on how to do that. If you need others, we can certainly come up with a video for how to talk about factoring things that have an A and a C. I've seen a lot of different techniques. I've seen students that write things on opposite corners of a cross. I've seen students that have done things where they do this like 3x3 grid. So there's a lot of other techniques I've seen, but the way that I showed you for the 7p squared plus 25p plus 12 is the way I feel is most straightforward for me. It might not be more straightforward for you, but it works. And so these other questions, is there anything terrible? Well, not any more terrible, but there might be some other ones that have awful, awful factoring. The final thing to consider if you have to factor is you can always use the quadratic formula. I know that at a glance you're gonna go, I don't want to plug into negative b plus or minus the square root of b squared minus 4ac all divided by 2a. But the reason I bring that up is because if you were to say plug it into a calculator or a computer that's going to solve it for you, um, this 3p minus 8 times 7p plus 4, what it would actually do is it would give you the two numbers that equal 0. So those numbers would be 8/3 and negative 4/7. And you can see where the 8/3 comes from here and the 4/7, and it's going to be the opposite of this sign. So there are a couple different ways to get there. I hope you don't have to do any of this, by the way. I'm hoping that this is all precautionary. The last thing that I'm going to throw in, because I don't see it here, is what happens if there is more than two fractions to deal with. So what if you had, for instance, x over y squared times yz cubed over x y to the third divided by z squared over xy. Nothing changes. Step one, flip anything that is divided by. So x over y squared times yz cubed over xy cubed. We didn't change this because those two were multiplied, but the third one we're going to flip. And then we're just going to cancel whatever we can. So we can cancel a x, we can cancel a y, we can cancel a other y, we can cancel a z, or two z's actually. And let's see, we've got a z here, we got an x here, we got three y's on the bottom, so that's just x times z over y cubed. So hopefully that gives you a rundown of how to approach these. They are really not any different than what you would have seen when you were simplifying. Again, the only thing to watch out for really is flip the division. Yes, this particular set of problems, unlike the last one, had some really gross quadratics, but that's just amping up the factoring process or step of the process. The overall procedure is still going to remain basically the same. So I hope that helped.